Welcome. My name is Markus Grün. I'm here at OFC 2025. Join us on a booth tour around what we brought this year. This year we have a special focus on AI, data networks, and data center demands. So we have 448 gig, for example, a new solution that we brought. We have 1.6T solutions for interconnect, as well as design, and so on. So please have a look what we brought.
Hi, my name is Chi Lam Chen, and I'm the product manager for Sampling Oscilloscope. I'm excited to introduce the new N1093 DCA-M sampling oscilloscope, featuring the high sensitivity optical channel with integrated clock recovery up to 120 gigabaud. For the first time in the DCA family, we have integrated the precision time base to achieve 90 femtosecond jitter. The N1093 is designed to meet the demanding needs of 1.6T transceiver optical testing for R&D and manufacturing, enabling the next generation optical interconnects for data center AI cluster.
Hello, I'm Stefan Löffler, Product Manager for Photonics with Keysight Technologies. To introduce our PIC testing solution, let's visit our partner FormFactor at their booth. This CM300 wafer prober by FormFactor is equipped with a Keysight tunable laser, polarization synthesizer, and multiport power meter. The entire system is controlled by FormFactor's test executive using our Pathwave test plugin and our polarization lambda scan software. By swapping the power meter for a source measurement unit, we can test photodiodes for responsivity over wavelength. This product family covers 1240 to 1650 nanometers, and with up to 3 lasers and an optical switch, the software combines their wavelength sweeps into one trace. To validate the design and prove the functionality of a modulator or a photodiode, we use a lightwave component analyzer. To measure the modulator's bandwidth and phase response by feeding it with RF and connecting its output to the LCA's optical input. For photodiodes, we stimulate them with a modulated optical signal and measure their frequency response, adjusting bias with the source measurement unit. Wafer probing and test systems can perform thousands of measurements on a single wafer at various temperatures and operating conditions, just by combining the test equipment I've shown you today.
The demand for energy-efficient high-speed interconnect is skyrocketing. Last year, Keysight introduced the industry-first complete validation solution for 800G linear pluggable optics, short LPO. This year, we are taking it further with a validation solution for 1.6T low-power interconnects, running at 224 gigabit per second and per lane. It supports both LPO and real-time transmit linear receive technology, short RTLR. Designed for future scalability, this solution aligns with future standards that are expected to mature by 2026. For more information, visit Keysight's website. Thank you.
Well, hello. Welcome to Keysight's OFC 2025 booth. I'm here to talk about the Photonics Designer product. It's a brand new NPI from Keysight. It addresses 2 key issues with designing photonics integrated circuits. One is integrated workflows, which the industry is lacking of today, and the other is accuracy, which is also lacking in the industry today. We accomplish this with using the ADS platform, which is a high-frequency design platform, very well suited for photonics design. And we use very deep physics models that are embedded in the product, which provide unprecedented accuracy. The workflow itself is all done within one suite, and it's also integrated in the same ADS environment that our high-speed digital designers utilize for their high-speed digital design. So therefore, we now have electrical, optical, electrical workflow solution for our customers. The accuracy is also shown here in this top chart, where we're showing measurement versus simulated results as a demonstration of how we achieve accuracy with a hybrid twin. And the hybrid twin uses a deep physics model, which is then updated by measurement data, and that measurement data then tweaks the model or adjusts the model. So now the whole palette of models in that process design kit are now optimized for utmost accuracy. 2 things to walk away with. One is integrated workflow, unprecedented accuracy. If you're desiring more information or you have any questions on the solution, please visit our Keysight website.
Hello, I'm Charles Seifert, Senior Product Manager for High-Speed Ethernet for Keysight's network test measurement business. Today, we're debuting our 1.6 terabit Ethernet traffic generation and analysis product. We have 2 ports of 1.6 terabit Ethernet running today, sending line rate layer 2 traffic and doing forward error correction analysis so that we're able to prove the system level performance of these optical transceivers that are running 1.6 terabit Ethernet on each one. We can determine how well it will perform in a real-world data center network. So one of the interesting things we're doing today is we're transmitting 2.3 billion packets per second. And as an impressive feature, we are analyzing each and every packet in real time to give you an idea of the processing power. And the purpose of this measurement systems is to qualify the performance so that when a large company that builds hyperscale data center or a service provider has a large data center, they can predict how well these devices will work in their network.
Welcome to OFC 2025 in San Francisco, and I'm here standing at the Keysight booth on coherent optics testing. My name is Jörg Pfeifel, and I'm the optical components measurement scientist who wants to show you this demonstration here in a brief words. So we're mimicking here a complete optical transmission system for coherent, roughly 1.2 terabit per second transmission using a 160 gigabaud signal with a 16 QAM modulation format. We're generating that signal using the Keysight M8199B arbitrary waveform generator and use the software, our optical modulation generator tool, which mimics a coherent optical DSP for setting up the signaling parameters and de-embedding the waveforms. We modulate the signal onto an optical carrier using the optical multi-format transmitter, which also supports 85 gigahertz of bandwidth to allow us to go up to the 160 gigabaud that we're showcasing in our demo today. And we're receiving the signal and analyzing its signal quality using Keysight's N4391C optical modulation analyzer with 110 gigahertz of optical bandwidth. This device comprises a full coherent receiver, a fully calibrated coherent receiver, and an oscilloscope running at 256 gigasamples per second based on Keysight's UXR series oscilloscopes. We're analyzing the signals using the Keysight Vector Signal Analyzer software, which mimics a DSP of a coherent receiver, and it's demodulating the signal to show constellation diagrams and evaluating signal quality parameters like the error vector magnitude, any type of signaling impairments that are still present on the signal, as well as bit error ratio measurements if the bit pattern is known.
Hi, my name is Fabio Pitala, and I'm a product planner at Keysight Technologies. Today, I'm excited to demonstrate 448 gigabit per second using 224 gigabaud PAM4. The demo used the powerful Keysight M8199B AWG linked through an high-performance frequency domain multiplexing unit. The output 224 gigabaud signal drives an externally modulated laser from Lumentum. The signal is detected and analyzed by using the Keysight N1032A DCA-X. Even if we continue to explore the balance between higher symbol rates and advanced modulation formats like PAM6 and PAM8, today we have proven that PAM4 can remain a leading format for next generation AI data center moving to 1.6T, 3.2T and beyond.
Hello, I am Alex Bortek, a product manager at Keysight. Today, Keysight announced a new product, Kai Data Center Builder, that allows us to emulate AI workloads. This allows us to bring in into a lab environment a system that allows to benchmark performance of AI infrastructure without need of expensive GPUs. This system is part of a larger portfolio of Kai solutions and focused on benchmarking the network infrastructure today. And later we're going to expand into other areas with compute, interconnect, and power measurements. Our system allows customers to benchmark either performance of elemental building blocks of AI workloads called collective communications, or replay the whole workloads like Llama 2 or GPT over the infrastructure, performance of which you want to measure. Even more, we cover the whole range of solutions, starting from pre-silicon chip design to individual component testing the whole system in its full complexity, as well as validating deployments of GPU into the clouds. This is all provided by Keysight Kai Data Center Builder software that we demonstrate in this station. Thank you.
Thank you for spending your time with us. Hopefully you find all the solutions that we brought this year also so exciting that I do. So if you have any follow-on questions, do not hesitate to contact your local Keysight representative, as well as all the people that you know in Keysight, or visit keysight.com to get your contact. So thanks for joining in and hope to see you soon.